I'm going to talk to you about the Multipeer connectivity framework. So the reason why I got into this mess is because of my roommate. He made a game. He's a very creative dude. And this game is sort of a haunted house / scavenger hunt type game. And basically how it goes is it's turn-based. There's 30 seconds of lights on and 30 seconds of lights off. And how we do it is we usually get an entire house and then usually do it on Halloween. One time we did it in like an office complex, which was super awesome. But you have like an entire house and it's totally dark and everybody just has a flashlight. And so everybody has 30 seconds, and when the lights are on, you can like scavenger hunt through your room and like maybe find objects, and they use the objects to win the game somehow. And then 30 seconds of lights off, and when the lights are off, you can move between rooms. So this is a lot of fun, and we've done it a bunch of times. But there's a problem, which is the genesis of every really great app out there is you have to solve the problem. The problem was that all the lights need to be turned on and off simultaneously. And this is how we usually had, everybody had little flashlights. And in our first iteration of this game, the first time we played, we literally just had 2 or 3 people who weren't actually playing the game, who were just the hosts of the game. And they just walked through the house and just yelled, lights on, lights off, which is, it got the job done sort of, but it wasn't really the most efficient solution because usually there's somebody in the basement and there's somebody else in the attic and then they can't hear you and then that's just awkward. So our second run through the game, we were like, all right, we got this. All right, we're gonna have radio-controlled lights, and I don't know if you've ever seen these little fake candle porch lights, and they have a little clicker, and you can click them on and click them off. And we were like, all right, we're geniuses. This is totally solved. We got it. And it kind of worked, but the problem is the little click signal doesn't actually go through doors or walls. So you had to still go into every room and click it off and then click it on, and it's not a good deal. So then my roommate came to me and he was like, oh, hey, you're doing the app thing. Wouldn't it be cool if you could make an app that could turn people's lights on and turn people's lights off? And I was like, yeah, that would be cool. And he was like, can you do it? And I was like, I have no idea. So I asked around, and basically what everybody told me was you need to have a server, you need to have people sign on to the server and create accounts. In order to get permissions and to go into people's device settings, it turns on and off, and I was like, that seems like a lot of work that I really don't want to do. But then I was on Reddit one day and I saw an article about the Multipeer connectivity framework, and it pretty much does everything that we want it to do. And that is a picture of my friend Sarah scaring the crap out of me during one of our games. I was hidden in the basement and I heard her coming down the stairs and it was totally dark. And I was like, I know, I'm going to take a picture of her and startle her with the flash. What I didn't know is that Sarah is extremely quiet and was about literally less than a foot from my face when I actually took the picture, and actually ended up scaring the crap out of me because she's a genius. So, actually, what is the Multipeer connectivity framework? Well, what it is it basically allows devices to communicate with each other directly over a common Wi-Fi network. So there are 4 main components of it. There are peers, sessions, browsers, and advertisers. And I'll sort of go over what each of those particular components mean, and then at the end I'll sort of show you how to use them all together. All right? Okay. So peers. Peers are the simplest part of the system. And a peer is basically just your device. It's a thing that you initialize that says, I am a unique thing, and I have a name. And that's really all it is you have a thing and you have a name. And it's usually the first thing you do when you're doing any sort of multi-peer thing is you just create your peer. And each device has a peer, and when you're logged into somebody else's session, you can see their peers, but you can't ever change or edit another peer's ID or identity. And you can't even edit it yourself once you create it. So the next thing is the session. The session is the real workhorse of the multi-peer format. Basically, the session allows other peers to join into it. You require a peer to initialize it. It's actually pretty simple to set up, to quote-unquote set up. But it has a lot of stuff going on behind the scenes, and a lot of the methods you call are going to be called under the session. It has a property of connected peers, which is basically like just an array of everybody who's inside the session that you're in currently. And then whenever you want to do anything with those peers, you usually call that property. And then it has states that it can tell you about, and we'll go over that a little bit later. There are two types of browsers. The first one we're going to talk about is the browser view controller, which actually just presents a sort of baked-in view controller, which has a list of people who are advertising for your service. A service type is a thing that was really confusing to me beginning this, because the demo that I sort of built my app, like the prototype of my app for, had a service type. It was like a little chat app, and its service type was like LOC-service chat, and I was like, oh, is that like a specific thing? Like, is there like types of services that I just don't know about? No, there are none. It's just a thing that you totally make up yourself, and it just has to be a unique string. So basically, there are browsers, and the next thing we're going to talk about is advertisers. And the browsers and the advertisers need a way to be able to flag each other to say like, oh, I'm advertising for this thing, or I'm advertising for this thing. Oh, well, I'm browsing for this thing, or I'm browsing for that thing. So I can connect to a thing that is advertising, so a browser will connect to a thing that is advertising for the service that it is advertising for, if that makes any sense. So it requires a session to invite peers to. So you can see that there's sort of like a waterfall of things that you have to initialize. Like you initialize your peer, and then which requires you to initialize your session, and then your browser requires a session, which requires a peer. So there's sort of like a natural order in how you set this up. The second type of way you can do it is just sort of have it automatically, your browser just automatically accept anybody who's advertising for your service. So like, instead of having an actual view controller pop up with a list of people who are saying, hey, I would like to join your app, like a lot of the time, anybody who's advertising for your service, you're probably going to want them to join, right? You're not going to be like, all right, I want this guy and that guy, but not Jim. He doesn't get to play today. So, I mean, a lot of times that's not going to be the case. It's just anybody who's advertised, you want to automatically bring them in. So the nearby service browser allows you to do that. It basically just will continually browse, and then anybody who is continuously advertising, you can just like, as soon as it sees, oh, there's somebody who's advertising for my service, you just pull them right in. So advertisers I've already talked a lot about them, but they handle a lot of the UI, and when you set them, they just basically broadcast that they are looking to join a service of a certain type. And as long as it is the same service type, so it's the same unique string of the browser, it'll automatically connect the two. So there's two like sort of main phases for this. There's like the discovery phase, which you do all like the setup, you initialize everything, and then there's the session phase, which is you actually like do what you intend your app to do. So the first step is you initialize a peer. It's pretty simple. You just initialize it with a display name. You can call the UI device current device to just get your device's name, like how you always have, your device always has like a little cute name that you name it, and then that usually pops up whenever it has to read anything. So that's just sort of like a default thing that they use. Then you initialize a session, and you use the peer ID for that. It's pretty simple. You set its delegate. And then you initialize a browser. You use your service type. For instance, my service type is demo for this app. And then you have to have a session for that, and then you set its delegate. See, all this stuff is like pretty simple. We're already like mostly set up. And then for setting up your advertiser, this really depends on how you're going to structure your app. So like a lot of the more simple examples that you see will have just everything like one view controller, and then it will automatically give everybody an advertiser, automatically give everybody a browser. So everyone will be browsing, and everyone will be advertising, and then just like one person will be the person that invites everybody to their session. And that's fine, it works. But the way I have my app set up is that there's like two main sections of the app. There's like a host section and then a client section. And when the host section is the person who's browsing. So the host is really the only one who needs to browse because nobody else would need to do that. And the clients are the only ones who are advertising because they need to join a person who's browsing. So, I mean, it really depends on how you want to set it up. There are many different like design patterns you can do for it. And you can see in this, like, this is a thing that sort of confused me. Another thing that sort of confused me when I started out was that even though you're advertising and you're joining somebody else's session, you still have a session object of yourself. You can't, like, not create your own session and just join somebody else's and have that be good. Because how it works is you just, is when you join somebody else's session, you set your session object to be equal to theirs. So, so it's not like you're discarding your session object, you're using theirs like you don't need one. Everyone has a session object, and then they just, like, you just, like, set yours to be equal to theirs, if that makes any sense. Okay, so now, so we have a session, we have a browser, we need that browser to search for advertisers, so if we're going to use the view controller, it's literally as simple as just saying, present view controller. So you just, like, call whatever you initialize your browser to, you know, you bring it up, and then that's really all you have to do. It's really very simple. Like, a lot of the power behind this is done behind the scenes by the framework. So this is sort of a cool thing, is that when you have a peer that changes state, you can do stuff with them. So when a peer connects, if you want to, like, grab that peer's name and send it off to an array to display, you know, in, like, a table view somewhere, so you can see, like, who's in and who's not, you can do that. And that is did change state method is used for that. And so there are 3 possible states: it's connecting, connected, and then not connected. So I did something like this in my demo app, so when we look at the code for that a little bit later, you can sort of see how I set it up. But you can do a lot of, you can probably, you probably imagine you can do a lot of interesting stuff with this. Sessions are limited to 8 people, including the host, so a total of 8 across everybody. There is a possible way to hack around this, I think. I did set that up for my app, so we can take a look at that a little bit later. But I haven't actually tested it with more than 8 people, so I don't know if it actually works. But in theory, it should. All right. So now we're into the session phase, which is where people actually do, what your app intended to do. And how you do that is you, to communicate with other peers, it's pretty simple. You just call this send data. All data that you transfer between peers has to be in NS data format. So, you can send strings, you can send whatever you want, as long as it can be translated to NS data. And then two peers, depends on who you want to send it to. So you can send it to everyone by just calling, session connected peers. Or you could send it to just a single person by just, like, going through an array and picking out, somehow picking out a single person that you want to send it to and just sending it to that person. There is the with mode. The 2 options for that are data reliable and data unreliable. So what you want to use that for is that if you are sending data that is like, your app is really, really dependent on that data being like 100% accurate and intact, like it's going to totally blow up if it's not right, then you probably want to use data reliable. Whereas like my app is just like, maybe somebody's light doesn't turn on or turn off, at the right time, not super important, so data unreliable is better for me. And that's because like, you're sending information across a Wi-Fi network, and like if that Wi-Fi drops, then, oops, who knows? So then to actually use the data, you have a function that just says did receive data, and you get the data, and you have the session, and you have the peer, and then you just do whatever you want to do with it. And that's really like the main parts of the app. It's not as nearly as complicated as I had thought it would be. And then when you want to exit a session, all you do is just call session disconnect, and your session object is basically disconnected from the, it's basically reset, essentially. But wait, there's more. There's a couple other things you can do. I haven't actually done any of these in my app, so I just wanted to let you know about them in case you wanted to do them. So if you want to be a little more adventurous than I was. You can send resources. So like say you have a large picture that you want to send somebody. You don't actually have to like have it downloaded on your phone and then send it through your data. You can just send them the URL, which is kind of neat. And you can also stream data. So like, I haven't actually had a cause to want to stream anything, but if you wanted to, you certainly apparently can. All right, so now we are going to tempt the demo gods. I have 2 phones here. I have 11 new Slack notifications. So how we're going to do this, because I'm doing this presentation at my school has a very secure Wi-Fi network. It does not work on my school's Wi-Fi. I've never been able to get it to work. So what I'm going to do is set up a, oh, looks like I already have it set up. So I'm going to set up an ad hoc network on my laptop and then sort of run both of my phones through there. So I'm basically doing the exact same thing on my phone that's not on the display. All right, so we're both on my ad hoc network now. And I'm going to fire up my app called Live Action Betrayal, which, by the way, is in the App Store, so if anybody wants to go download it and play with it, feel free to. You increase my downloads by probably 100% every time you do. All right, so I will show you guys on the phone that's displaying, I'm going to show you the Watcher section, so this is like the admin section. And then on the phone that's not displaying, I'm going to show you guys well, I guess I won't be able to show you guys, but this will have the Explorer section, so this will be the client side. And first off, I'm going to click this button, Browse for Devices, and on my other phone, there's a similar button in place called Connect to Watcher, and it will connect, and it will take a couple of seconds. I originally had the browser view controller pop up, where it just popped up, but then I was like, since we are, since this is made for a non-technical person to use, I want it to be like as little clicks as possible in order to get it to do what it actually did. So using the nearby service browser just made more sense for me. All right, so you can see a little pop-up thing says peer connected, and I actually had to add that. That doesn't come standard. And then on my table, you can see my phone. My phone's name is Plato. You can see that's connected, and now I can do whatever I want with the phone. So you see there's the light section, so I can turn the lights on, turn the lights off. If there's an individual person, turn the light on, turn the light off. And then I also have a little timer because it's meant to be on 30-second intervals, so you don't have to do like a separate stopwatch. We'll just do 3 here for the sake of the demo. So timer counts down, light comes on, timer counts down, light goes off. Pretty simple stuff. I also have a messaging system. This is sort of rudimentary. A lot of the times how this worked was that it originally started with just lights, and then my roommate was like, oh, I also like to be able to send messages. And I was like, all right. And so I sort of like created a messaging system, and then he was like, oh, I'd also like to be able to send messages to a specific person. And I was like, okay. And then it sort of just, got into just a huge boondoggle. But there is a messaging system, so if I want to send a message to all explorers, they have like these preset messages, and then if they wanted to like type into a thing, and then that shows up on my Explorer's phone. And then haunts, which are like the guides. So there's like specific different games you could play within it. So within the objects that are hidden throughout the house, you could have like different scenarios. Like one of them that we played was you had to find 4 different objects and then go to a certain room in the house and then like pass a certain like stats check in order to be able to do it. But so if you wanted to have like different scenarios all available to you depending on whatever happens throughout the game, there are different like guides you could put in here. But I don't have any on my phone right now. How you get them onto there is I just used iTunes file sharing to just put a text file on there, which was actually probably one of the most complicated things I had to do for my app, which is sort of interesting. And then so once you select it, and you can then send it out to all the people, and then it would display on their phone. And that's really all it does. It took me pretty much all summer to build for how simple it is to display. So if we want to take a look at some code here. So you're going to look at this, and you're going to probably very often say to yourself, boy, that's an interesting design decision. I wonder why he did that. And the answer is almost going to universally be, because I didn't know any better. So keep that in mind while looking at this. But basically, the very high level of this is you have your MC Manager class, and this is the thing that handles a lot of the multi-peer stuff. So all of the methods that you saw in my PowerPoint a lot of them are put in here. And then I initialized it in the app delegate, and then whenever I needed to call it, I just called it from the app delegate. And that sort of works. It's sort of like a hacky way of doing a singleton, but I didn't know any better at the time, so that's how I ended up doing it. But if we want to look at it, actually what's going on here, so we have two different sections. The Explorer section is the client side that I told you about, and there's the Watcher section, which is the sort of admin side that I told you about. And because I was very green and naive when I made these, pretty much all of the code is right in the view controllers, because that's how it's supposed to be done, right? But it does make it a little easier for presenting. So if we go to the Watcher section, so this is sort of the admin side of the app, and in the Connections tab, you can see that, once again, first thing we're doing is we're creating a peer, we're setting the peer display name, and then we're creating we're setting the state. And then, hold on, wait. So here we go. In the viewDid load, so we have setup peer in session, which is a method in here, which basically takes care of all of the initialization. So all of the things that I told you before with the steps, initialize your peer, initialize your session, initialize your browser and advertiser if you need to. Those are all done not here, but in here. So set up peer and session with display name. And you can see this section, this class, is not that large, and most of the methods in here are the required ones that we don't need to use. So there is a bunch of the required methods for streaming and sending resources. They're required as part of the protocol, so you just have to have them in there even if you're not going to use them. So really the only methods we're going to use in here are set up peer in session, advertise self, which starts and stops your advertiser, set up your browser, which shows the view controller, and browse. And that's really all we're doing. So remember when I told you earlier that there's a possible way to get around the 8-player or 8-person maximum? So there's a discussion on Stack Overflow about how it could be possible to do this. And what we came up with was you create an array of sessions, and so then you have an array of sessions, and then you just grab an available session. So that you just see how many people are in a current session, and then if there are less than 8, you just grab that one. And then if that session is full, you create a new one and then add it in there. But the trick with that one, with the way of doing this, is that you would have to, anytime you want to send data to anything that's to a specific person, you have to find which session they are in, and that can get kind of tricky. But it works with less than 8 people, so I haven't actually had the chance to try it out with more than 8. So I can't actually speak to if this works or not, but yeah. So we create our session. How I go about basically pinging whether a data was sent and received. Since it's in a separate class, I use the notification center. So I use notification center, and then you basically call a method. So in this one, you say did change state notification, and then that calls this guy, which says so you get a notification, and you have a peer and your display name, and you basically say if it's not connecting. So if the state is not connecting and the state is connected, then you would add it to this array, which showed up, which you saw. And then if it's not connected, then you basically take it away from the array. And there's some UI bits in there, which I never actually cleaned up. But that's basically all it does. And then here's the alert view, which pops up when a peer is connected. And yeah, I mean, there's a lot of code in here, but it's all pretty simple stuff. So when we're actually sending data, so when I actually click the lights on, lights off button, what's happening is I'm sending data to this class, or this view controller. And what it's saying, so I have the notification center set up to say, did receive data notification. And basically what that does is it works its way down to basically these two methods, which are pretty small, which just, if it received a notification that was 1 byte long, it turned the light off, or turned the light on. If it receives a notification that's 2 bytes long, it turns the lights off. That was a decision that I made completely arbitrary, because at the time that I made it, really all the app was doing was turning the light on and off, and so I was like, well, it seems pretty simple. 1 byte long, it's on. 1 byte off, or 2 bytes, it's off. It seems pretty simple. That came to burn me later when I set up the messaging system, and then I found out whenever you sent a message of 1 character that was 1 byte long, so it turns the lights on and off, which was a little awkward. So what I ended up having to do was basically create a minimum length for the message, which was not ideal. So this is just sort of a demonstration of how design decisions you make for the short term can come to burn you in the long run. And then, so there is also a blackout screen, which I created because it's a haunted house app. So we didn't want ambient light during the lights off phase. You didn't want ambient light from the phone screen, so it just basically blacks out the screen. And then sort of something very similar with the Haunt view controller. So something similar for the messaging system. So in here there's a message alert. And so this basically says if it's 3 bytes or greater, if it's between 3 bytes and 140 characters, 140 bytes, then it displays it in alert. And you might ask, why between 3 and 140? Well, because I'm basically using the same thing to send the haunt, basically the guide, along with it, and that guide is going to be very long, so it's going to be over 140 characters. So I was like, all right, I'm just going to limit them to basically tweet length. You shouldn't really ever be having to be typing that much on your phone because this is supposed to be for very simple messages like game is over, somebody won, somebody's the traitor, etc. And so all it does is it comes in and it unpacks the MS data into a string, and then it puts it into alert view. And that is, and then so we can take a look at the explorers. So the Explorer side, which is the client side, it's even simpler than the admin side. Is you have your notification center, and then you set up your peer in session, and then the big difference with this one is you have an advertiser. So basically for this one we call advertising start. That's how there's a start and stop method for the advertiser. So you just call .start, .stop. And so basically the big difference for this one is we don't set up a browser, but we do start our advertiser. So, and that's, other than that, it's pretty much, it's very similar. The UI is a bit simpler because you don't need to select anything, or you don't need to see a table view of connected peers. You just need to have a big green connected button or a big red not connected button, and then the button for connecting. And and that's essentially my app and what it does. It was a journey to build, and even though we have not been able to use it rigorously, it was a lot of fun, and it gave me a really good head start for working in class here. So that is a Multipeer connectivity framework. Does anybody have any questions? Accolades. I know some people in here are looking to do it for their projects. Do you guys have any questions for me you'd like to pepper me with?
Not yet.
Not yet. Okay. Acceptable answer.
So
I guess I have a question, and it's, unfortunately it's nothing to do with the code, it's to do with the
Sure.
game.
Yeah.
So, it seemed like the problem in the game was turning the house lights on and off.
Oh,
And
individual lights. So they have like little flashlights
yeah,
that they need to turn on and off? Yeah.
so flashlights just built into the phone that automatically go on and off. Is that it?
Correct. Yeah.
Okay.
Yeah. So, for instance, like iPads do not work for at least for the Explorers because they don't have LED lights.
No.
And there are certain older versions of the phones, like iPad Touch or the iPad Touches. I don't think they also don't have LEDs. So you can use an iPad as the host device because the host device doesn't need to have a light that works or not work. You know, so that's possible. But for all of the client-side devices, they all need to be actual phones that have an LED device.
So you search around with your flashlight, and then for the other 30 seconds, it's completely dark.
It's completely dark, and you like sort of are stumbling between rooms, and there are obstacles set up, and
That was my misunderstanding.
oh yeah, it's good. Thank you. Live action Betrayal. Yep. If I had to change anything about the app, it would definitely be pulling a lot of the code out of the view controllers and into their own classes. There was a lot of times where I wanted to access something, but I just didn't have the know-how at that point for like enough object orientation in order to be able to like realize, oh, I should just pull this out and then do something with it then. I would also change the UI. It's also really not attractive. So if I could change two things, it would be updating the UI to look a little nicer and be more intuitive, and to make it a little more object-oriented.
Changing the NS data messaging system a little bit?
Yes. Also, rip out most of the messaging system, I would say, would be the best thing to do.